In this session, I'll be talking about comparison tests of continuous responses, and I'll be using Minitab to illustrate how you can use the software to do basic analyses. So what I'll be now do is I'll open a data set here, which is example 2201. As you can see, you've got samples from two different populations. One is listed as current and the other listed as new. So we basically, first we want to test to see if we believe there's a statistical significant difference between the two samples. So it's a two-sample T. In this particular case, we've got its own column. So one is current and the other is new. Now we have options to test very alternative hypotheses, where we could say one is less than the other or greater than the other. We're going to leave it as our alternate hypothesis where they're not equal. So when we do this analysis, then this is the output that we get shown in the session window. So the method that we're using is we got the mean value, that's the current, difference is mu1 minus mu2. Under descriptive statistics, we see that we have 14 samples for each of them, got a mean and standard deviation. We also got the standard error shown for the mean, which is, you should recall, is the standard deviation divided by square root of n. This particular value is used when calculating confidence intervals. The estimator for the difference, the best estimate, is you just simply subtract the two means, which is shown there as 0.32, and then you also can calculate the 95% confidence difference. Under tests, you'll see what the null hypothesis is, mu1 minus mu2 equals 0, which is the same as mu1 is equal to mu2. In this particular case, the t-value is calculated to be 5.5. The degrees of freedom for comparing this particular information would be 19. Turns out the p-value is very low. It's much less than 0.05. So therefore, we believe that there's a significant difference. Now, there's another option that you can have here, stat, basic statistics, and you have a paired t-test. So a paired t-test is useful whenever you've got a situation where you might have a sample going through two different test stations where each of those have a response. And then you want to look at the difference on the measurement. And those are actually paired physically because each of those samples went through basically the two different measurement systems. And that's another way you can use this particular function, but that's called a paired t-test. So the application of this technique is where you can look at the differences between the current and new process change when you got a continuous response and you want to get back to the raw data, which actually this is, or let's say, for example, within the overall variability of our process that we're trying to improve, we want to see if there's a difference between two suppliers, then this technique would be applicable. But this technique is only applicable when there's two. Now we'll talk about other techniques later where you can have more than two.